Hello students, in this video I will go through a lesson on how to find the slope of a line and go through some examples where we have to work with the slope formula. Let's take a look. So suppose I ask you to find the slope of a line that passes through 1, -1 and 5, -4. How would you go about doing that? Because this topic is so visual, it is really necessary to be able to see this on a coordinate grid. So what I'm going to do is I'm going to try and graph this out to show you what I mean. So I plotted 1, -1 and 5, -4 as so. And a way to tell, and recalling from the days of studying algebra, the sign of slope, and what I mean by sign, whether or not it's positive or negative, right? That's what I mean. So if I were to connect these two dots, okay, the direction that we're moving in is always going from left to right. And looking at the line in this manner, you can see then this line, okay, is actually going down, which implies that we're going to have a negative slope. This is how you can tell whether or not you are performing the algebra correctly or not. So let's find out what is the slope of this line segment. So in order to do that, we have to understand a little something about the slope formula. The slope formula goes like this. This is change in y or change in x, or y2 minus y1 divided by x2 minus x1. And the way to think about this is you're going from left to right, so that means you're going down and then you're moving to the right. Or in other words, you're finding out what is that change in y and what is that change in x. Commonly referred to as rise and run, right, when you guys were studying this in Algebra 1. So if we apply the formula and I label x1, y1 and x2, y2 on the 2 points that are given, I can then directly substitute those values into the slope formula, and I can find that my answer does indeed turn out to be negative. It is -3/4. So we go down 3 and we go over 4. Let's take a look at another example. So same situation, different coordinates. I'm asking you to find the slope of these of the line segment formed by these 2 points here. So again, my attempt is to show you this graphically, okay, and I can see now when the 2 points are plotted on the coordinate grid that these 2 points are actually on the same level. I would describe this line segment as being horizontal. So if I were to apply the slope formula, right, x1, y1, x2, y2, I would then figure out that the slope of this line segment turns out to be, because there's no rise or run, there's no rise, but there is run, the slope turns out to be 0. And as a matter of fact, all horizontal lines must have a slope of 0. This is a fact. All right. Same problem, different coordinates. Let's take a look. So again, I'm going to plot this out on a coordinate grid, and I can see that the points are one on top of the other. And seeing this line segment in this manner, and then applying the slope formula, I can then see that the slope value turns out to be, because there's no run here, I'm dividing by 0. And we cannot ever divide by 0. That's undefined. It doesn't make any sense. We cannot divide by 0. So because of this is a generalization that we can make. Anytime we have a vertical line, the slope of a vertical line will always be undefined. Or you can even characterize it as having no slope, which is different from 0 slope. Let's take the algebra up a notch, right? So different problem entirely. So find the missing coordinate that forms the line with the given slope, while passing through the given points. So I'm telling you what the slope value is. I'm telling you what one of the coordinates are, and I'm telling you partially the other coordinate. I'm only giving you the y coordinate, and I'm asking you to find out what the x coordinate is. We can achieve this, again, algebraically, by finding out what a is through the use of the slope formula. Let's take a look. So if I call the first coordinate x1, y1 and the second coordinate x2, y2, I can then directly apply the slope formula the way I see it. So I do y2 minus y1, so that's negative 4 minus 1, over x2 minus x1, so that would be a minus negative 3. And since this fraction here represents the slope, and the slope is negative 3 halves, I can equate this with negative 3 halves. And now what I have is an algebraic equation with only one unknown. I can cross multiply and simplify and isolate a. So distribute and then add 9 and divide by negative 3. A turns out to be negative 1/3. So the coordinate turns out to be negative 1/3, comma negative 4. Here is a graphic for all the formulas that we are going to be using in the next couple lessons involving slope, involving the equation of a line, perpendicular and parallel, which are concepts that you've seen and have worked with in Algebra 1, but here it is again. And there is a separate Google Doc where this can be found, where you can print this out and place it inside of your notebook where you can work with this